Paired t-test/paired sample t-test/dependent sample t-test, 3 marks. Introduction. This test is also known as dependent t-test, paired t-test, repeated measures t-test, correlated sample t-test. It is a statistical procedure used to determine whether the main difference between two sets of observation is zero. It is used to find an experimental effect in a single group before and after intervention. Definition. Paired t-test is used to test the mean of the differences between dependent or paired observations. It is a powerful technique to reduce sampling error. The paired samples t-test compares two means that are from the same individual, object, or related units. A paired t-test is used to compare two population means, where two samples are there, in which observation in one sample can be paired with observation in the other sample. Or when means of two sets of score are not independent. Resources. Use a paired t-test for dependent groups. It is used to find an experimental effect in a single group before and after intervention. It is a powerful technique to reduce sampling error. Example. Measuring cholesterol level of individuals before and after 2 months on diet. Researchers sometimes obtain two measurements from the same people or from paired sets of participants, e.g. siblings. When means for two sets of scores are not independent, researchers should use a paired t-test, a test for dependent groups. Example. The number of doses of medication needed for asthma attacks before and after relaxation training. Example. Suppose we were studying the effect of a special diet on the cholesterol level of elderly men. A sample of 50 men is randomly selected, and their cholesterol levels are measured before and again after 2 months on the diet. The hypotheses being tested are H0, 1 equals 2 H1, 1 is not equal to 2, where 1 equals pre-treatment cholesterol level, 2 equals post-treatment cholesterol level. At statistic then would be computed from pre-test and post-test data. Purpose. The purpose of the test is to determine whether there is statistical evidence that the mean difference between paired observations on a particular outcome is significantly different from zero. The paired samples t-test is a parametric test. Common uses. The paired samples t-test is commonly used to test the following: statistical difference between two time points, statistical difference between two conditions, statistical difference between two measurements, e.g. weight measurement before and after nutritional interventions on the same subject, statistical difference between a matched pair, e.g. matching anxiety scores among a pair of twins with another pair of twins, or a measurement taken at two different times, e.g. pre-test and post-test with an intervention administered between the two time points, a measurement taken under two different conditions, e.g., completing a test under a control condition and an experimental condition, measurements taken from two halves or sides of a subject or experimental unit, e.g., measuring hearing loss in a subject's left and right ears. Types of hypothesis. Null hypothesis. Alternative hypothesis states no significance, states there is a difference/relationship, difference/relation between variables h1, 1 is not equal to 2 ho, 1 equals 2 h1, 1 2, right-tailed, h1, 1 2, left-tailed. Steps for computation of paired t-test. 0 heading. The paired t-test for two population means 1. State the null and alternate hypothesis. Calculate the differences and state the hypothesis. 0 H0, 1 equals 2. There is no significant difference between sample and population means. H1, 1 is not equal to 2. There is a significant difference between sample and population means. 2. Specify/decide the significance level, A level. Find degree of freedom for paired sample. D.F equals n-1/e.g. n equals 10, n equals sample size, and then df equals 10-1 equals 9. If A level is not given, assume it to be 5%, 0.05. 1. Calculate D, the difference between the first and second paired observations, e.g. D equals xy, compute the sum of the calculated difference, D, calculate the square of difference, or D2, calculate the sum D square, that is D2 also 2. Calculate D bar. D equals Dn, calculate the SD using the given formula. D2 and n. Calculate T value, using the given formula. T is equal to T equals to determining the statistical difference. We refer a tabulated T value at 9 df, for the 0.05 level of significance. Stating conclusion *, if tabulated T value is more than calculated T value, accept the null hypothesis, P greater than *0.05. Since it is accepted H0, 1 equals 2, If tabulated t-value is less than calculated t-value, reject the null hypothesis, p0.05, h1, 1 is not equal to 2, we can conclude that there is a difference between sample, x, and population, means. The null hypothesis is rejected and the alternate hypothesis is accepted.